So in this video, we are looking at translating the parabola. Now, in order to see how a parabola can get translated, we need to look at it in a particular form. Now, completing the square, as we've talked about previously on this channel, is a really good way to express a quadratic in what we call vertex form of a parabola, or completed square form. Now, this is expressed in the form of y equals to a, which is your dilation, outside of x minus h squared plus k. Now, when we do our completing the square, it will give us something in this particular form. Now, from here, we can read that this is just our parabola y equals ax squared, but it's shifted by h units. So it has to be in the form of x minus h. So when it looks like this, this is shifted h units to the right and k units up. So if this was written as, for example, x plus 4, where the sign was different, your h would be minus 4, because this would be in the form of x minus 4. So this would be 4 units to the left. And similarly, if this k value was, say, -3, that would be 3 units down. So we're just looking at basically, in this particular form, reading off whether we go right or left. So if the sign here is negative, we're going to be shifting it this many units right. If the sign was positive, it would be going left. However, with this one, the plus k means it's going up k units. If it was minus k, it would be going k units down. Obviously, numbers will take the place of these letters, and you'll be able to see how this works once we complete the square. So if we look at this first example, we are sketching the graph y equals to x squared minus 4x plus 5. So we want to complete our square first. So when we complete the square, remember we are halving our b term and squaring it. So this will be y equals x squared minus 4x plus 5. And then plus minus 4 over 2 squared. And remember, we can't just add something out of the blue, so we have to subtract this thing again. So what we're going to get is I get y equals to x squared minus 4x, and I'm going to, just so you can see the perfect square part, I'm just going to move this part next to my 4x. This is going to give us our perfect square section of this. Because remember, when we complete the square, we always want to get a perfect square that can be factorized somewhere here. So we have this one here. I'm going to write the minus 4 and the plus 5. Now from here, this section is going to factorize down to a perfect square. So I'm going to go through this quicker because this is assumed knowledge for this course. But this will factorize down to x minus 2 squared and then plus 1. So this tells us when we look, we are translating 4 units to the right and 1 unit up. That's what this particular form tells us. So here it's 2 to the right, and here this means 1 unit up. Now, this part essentially gives us the coordinates of our vertex, because if we imagine our original parabola, it has a vertex at 0, 0. If we are translating 2 units to the right and 1 unit up, the entire parabola is going to move, but specifically the vertex will also move. So if we know where to put our vertex, then half the job is done, because this is a significant point on our graph. Now our vertex has been shifted to the coordinate 2, 1. Now from here, we can draw the remaining parabola. Now, before we do this, we need to kind of, to label our graph, we want these significant points here. So remember, we need our vertex, we need any y-intercepts labeled, and any x-intercepts labeled. Now, we can see that this parabola is concave up, so it will have a minimum turning point. So there will be no actual x-intercepts over here. We just need to find the y-intercept. So to find the y-intercept, I set x to equal 0, and I will get y equals to 0 squared minus 4 times 0 plus 5. So my y-intercept is going to be positive 5. Once I label that in, I can now draw my parabola in. So I'm passing through my y-intercept, I'm going through my turning point, and I continue up. So our turning point form, or our completed square form, essentially gives us where our vertex is going to be, and it will show us how our parabola has been translated. So here we have 2 units to the right, and we have 1 unit up, and the whole graph moves along with this. Now looking at the next one, we want to sketch the graph of y equals to minus 2x squared minus 4x. Now you can see here, where this particular one is different is now we have a coefficient of x squared that is not 1. So in order to complete the square, we need to make this thing here monic. So what I'm going to do is I'm going to divide everything here by -2 in order to make this coefficient of x squared 1. So what that's going to give me is I get -y/2 on this side. And the part over here, I know it looks a little bit confusing now, but we're going to deal with all this extra stuff around the y. But we want to complete the square first. So I get x squared plus 2x. And from here, I can basically, on the right-hand side, I can complete the square. So I get -y/2 equals to x squared plus 2x, plus I'm going to halve this b term, so 2/1, then square it, that's going to give me 1. And then remember, I can't just add something randomly, I have to subtract it, so it stays equivalent to this part over here. Now what I'm going to get is -y/2 equals to, this part here is going to factorize down to a perfect square, as it always does. So this part is going to become x plus 1 squared, and this bit here is going to become -1. Now that we have the perfect square, and we have this in completed square form, vertex form, I can now deal with this factor over here. I can get rid of this negative and the 2 on the denominator to get y on its own. So I can just multiply -2 to both sides. So what that's going to do is it's going to act on both of these things over here, both of these terms. So I get y on the left-hand side equals to -2 outside of x plus 1 squared minus 2. So from here, I can read off and look at these shifts, the translations that are acting on this. Now, this part here, remember, this is my A term. So this is just our dilation. But I can see that this part here, because remember from the previous slide, it's in the form of x minus h. So this is like saying x minus -1, where this part here, our h, tells us that we are going 1 unit to the left. So this part over here is 1 to the left. And this part here, the sign's negative, I'm going 2 units down. So everything is going to get shifted. So I go from my normal vertex, which was at 0, 0. I'm going 1 left, and I'm going, ooh, one moment, I've messed something up. When I've multiplied by -2 here, this sign is going to become positive. So I get +2 here. So instead, I'm going 2 units up. Okay, so we can see here, my vertex is going 1 to the left, 2 units up. So it's going to be over here. That's meant to be a -1. And then I can go about sketching my graph. Now, we know that this graph, because the coefficient of x squared is negative up here, and this dilation part here, this one is negative also. So I know that the graph is going to be concave down. So this is going to be a maximum turning point. So I want to label in my y-intercept and my x-intercepts. So we're going to find these one by one. To find the y-intercept, I'm setting x to equal 0. So I'm going to get that y equals to -2 times 0 plus 1 squared plus 2. 0 plus 1 squared just gives me 1, so I get minus 2 plus 2, which gives me 0. So my y-intercept is over here. And then I want to find my x-intercepts. So my x-intercepts I get when y equals to 0. So I get 0 equals to negative 2 outside of x plus 1 squared plus 2. I'm going to move this 2 to the other side. Now, when I divide this through, I divide both sides by negative 2. So I get x plus 1 squared equals to 1. And I get that x plus 1 equals to plus or minus 1 here. So one of my solutions is that x plus 1 equals to positive 1. So x is going to equal to 0. And the other is that x plus 1 is going to equal to negative 1. So x is going to equal negative 2. So here are my two intercepts. So once I have this in, I have my y-intercept, which is also an x-intercept, as well as my second x-intercept. And I want to just connect the dots. And there we have our graph. The completing the square, remember, just tells us where our vertex is going to be. So this is called completed square form or turning point form, vertex form, where I can tell what my horizontal translation is going to be, what my vertical translation is going to be, and what my dilation will be as well. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.